number 9 and 10, let's go ahead and take a look at those. Okay. Again, when we're looking at these questions, what we've been talking to ourselves about is, how do we know if it's a trig function or an inverse trig function, excuse me, a natural log or a power rule, all right? So we need to be able to look at these and kind of run them through those three options. So see if you can decide with the people around you what this is. Again, it's either going to be a straightforward power rule, a natural log, or an inverse trig function. Decide what you think. I hope you are having the discussions, well, it can't be an inverse trig function because this is cubed. Okay? Isn't everything in those inverse trig function integrals all squared? So we'd have to have an even power. We could have a fourth power or a second power or a sixth power, but cube's not going to cut it. All right? And then I hope you said, well, it can't be the power rule because if we were to rewrite it, it would look like this. All right, and we can't raise a power of -1. Okay, so therefore it has to be a natural log integral. And it would look like the natural log of the absolute value of 3 minus x cubed. Now again, this is coming from the derivative of the inside, that whole reverse chain rule thing. What is the real derivative of the inside? -3x squared. Okay, so how do we make a -3 go away? -1/3 out front. Okay, and then of course we don't want to forget our constant of integration. So that would be your final answer for number 9. Number 10, I think I stole this problem because I'm kind of creative like that, right from our assignment. All right, so again we're thinking about, well, if a quantity is to a power, that's got to go up, but what's up with that x on the bottom? Okay, talk about number 10 with the people around you. So if this is, again, the reverse chain rule thing, the power on this quantity has to go up. All right, so it's got to go up to the natural log of x, the quantity cubed. Okay, do you see any 3's anywhere in there? From that exponent coming out front, any 3's? Nope. How do you make a 3 go away? A 1/3. Okay. Now the question is, that I hope you're still thinking about, is where does that x come from? Well, isn't the derivative of the natural log of something 1 over that something? Okay, so this right here is the derivative of the natural log of x. All right, the derivative of the natural log of x is 1 over x, and that's how that x gets on the bottom. Okay, so you don't want to divide by x or do anything with that. Again, the derivative of the inside is 1 over x. That's where that's coming from. We don't have any constants or anything to get rid of, but we do have a constant of integration to add. All right, so that would be our final answer for 10. And we'll